In this video, we're going to start working on our own implementation of a tree data structure. Inside of my code editor, I'll find the tree directory and then open up the index.js file inside of there. And then of course, before we forget, let's also start our tests up. So we'll run jest tree test.js -- watch. Now when we see the test start to run here, you'll notice that some number of the tests are being skipped. So just like before when we were working on linked lists, some number of our tests are being purposefully skipped right now so that you can focus on just this first block of tests right here that are all about testing a node. So let's now open up our index.js file again. So here we are, and we'll take a quick glance at some of the directions. So we've got 3 steps, and we're going to start on, obviously, start step 1 at the very top. So our goal is to create a node class, or a class that represents an individual node within our tree. The constructor function of this class should accept a data property and also create an empty array for storing children. Remember, a node carries references to all the child nodes underneath it, and we usually make use of an array to store all those references. Also notice that we are supposed to implement these add and remove methods as well, and we'll talk about exactly what they are going to do in just a moment. But for right now, let's just focus on the constructor function. Now for the node class, this first implementation right here, we're going to implement this together. So rather than have you do your own implementation of it, we're going to take care of this one together just because it's a little bit more challenging and it's kind of esoteric or a little bit theoretical how this stuff gets put together. But as soon as we put together the node, you will then go and give a shot at implementing the tree on your own. So for just the node, we're going to take care of this together. And then for the tree, you'll give that one a shot on your own. So let's get started with the node. We're going to define our constructor function inside of here. So constructor, and if you look carefully at the directions, the constructor says that it should accept an argument that gets assigned to the data property. So this would be the argument that represents the data that we want to store at this particular node. And this can be any type of data, a string, a number, array, object, whatever it is. So we will accept that as an argument called data, and then we will assign it to this .data, like so. Now the next thing we have to do is to initialize an empty array for storing children, and we're going to assign that to the children property. So this .children equals empty array. All right, so that wasn't that bad. Let's keep going. We're going to continue by talking a little bit about this add method that we're supposed to put together. So let's take a look at a quick diagram that's going to help us understand exactly what it's supposed to be. So here's a diagram of a 2-node tree. So just 2 nodes. We've got one parent node, which is on the left, and then one child node, which is on the right. Notice how the parent has some data of 1, 2, 3, and the child has some data of 7, 8, 9. And the parent has a reference to the child node inside of its children array. So children array right here contains this node, and that's how we kind of implement the hierarchy of our tree structure. So the goal of this add function that we are supposed to implement is that we're supposed to add this add function. It will be called with some amount of data, and then inside that function we're supposed to create a new node and add it to the current node's children array. So you can kind of imagine that if we take this node right here and we called the add method on it and passed in some string of numbers, like say 4, 5, 6 or something like that, we should then create a new node and add that node to this one's children array. So the final structure would look a little something like this. So we would still have the parent node. Inside of its children array, it would have both the new node that we just created and the old one. So when we start thinking about how we're supposed to store this node in the children array, really don't overcomplicate it. All we're doing here is creating a new node and then pushing it into the children array. That's all that's going on here. There's nothing more fancy than that. It's just creating a new node and store it within this children array. So let's give a shot at the implementation of this add method. So back inside my index.js file, I'm going to insert an add method that will be called with some amount of data. And then inside of here, we'll create a new node by saying new node. We're going to create it with this data. Then we will take that newly created node and push it into the current node's children array. So this.children.push the node that we just created. Now, much like a lot of the stuff that we saw back on linked lists, we are creating this temporary variable here of node, which is 100% not necessary. So we can condense this down to just one single statement by saying this.children.push equals new node with data, like so. And that's it. That's all that is required for our add method. Let's save this and see how our tests are doing. So back over here, it looks like we now have 3 tests passing, and we still have 1 test failing, which is the test around removing children. So obviously we still have a little bit of work to do there. However, I do want to just come back to our node class. 1 second, I want to do one quick review because this is kind of the first taste of implementation here. So we initialized our data variable. We created an empty array of children. So every single node has this children array, so every child can have some number of children. We can tell which nodes are a child of a given node by just looking at the children array. So looking back at our diagram over here, we would have created some new node and then added 2 children or 2 new nodes to this thing's children array. All right, let's take a pause right here. We'll continue in the next video where we're going to start to implement the remove method on a node as well. So quick break, and I'll see you in just a moment.